Jai Jinendra, Namaste. My name is Sayyam Jain. Welcome to my channel. Today we are going to solve the 17th question of the problem solving series, which is based on arrays. So the question is, we need to find the majority element of in the array. So we are given an array and we need to find the element which is greater than the n by 2 number of times of the elements that are present in the array. So if there are 10 elements, then there should be one element which is more than 5 times, because 10 by 2 is 5. So if an element is more than 5 times in the array, then that element is a majority element. If we have a majority element in the array, we need to return that majority element. If we don't have it, then we will return either no majority element or -1. So let's assume that we need to return -1 for that case. So here in this example, we can see there are the total number of elements are 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, 9. So n is equal to 9 over here. Okay. So which element is the majority element? Is there any majority element? So we can see 3 has come 1, 2, only 2 times. 2 has come also 2 times. But 4 has come 1, 2, 3, 4, 5 times. So 9 by 2 is 4.5 and the 4 has come 5 times. So 4 has come more than n by 2 times. So 4 is our majority element. So we need to return 4. Similarly over here, if we see that 3 has come twice, 2 has come twice. How many times 4 has come? 1, 2, 3, 4. And how many number of elements are there? N is equal to 8. So 4 has come twice, or 4 times. So 8 by 2 is 4. So 4 has come n by 2 times. But is it a majority element? Or is 4 a majority element? No. It is equal to n by 2 but is not greater than n by 2. So what do we need to return in this case? We need to return -1, as there is no majority element. No element which has come more than 4 times in this array. So I hope the question is clear. Let's discuss what could be the solution. How do we solve this? So we know we can solve it with a very naive approach, that we can count all the frequencies of the elements, and we can check if any element has come more than n by 2 times. For example, if we are over here, so we can have a double loop and we can count for this 3, how many times 3 has come. So we count it, and then again when we check 3, so it has we already have the count. Then we don't need to count this 3, or we can count it again, no issue. We'll count it again. Every element will be counting the number of times it has come, and if the number of so we will get that element, or we'll store the element which has come most number of times, and what is the element. So we have already solved this problems in naive approach. So when we are using double loop, double traversal, so inner loop traversal, then the time complexity we know is order of n square, right? TC is order of n square. So in this way we can find the element which has come the most number of times, and then we see what is the count. Say for example, here we'll count when in the inner loop we have 4, and then we count how many times 4 has come once. Then we go here, it's not 4, we go here, it's 4, 2, 3, 4 times. So the element is 4 and the count is 4, that is the maximum. But we see that it is not greater than n by 2. So in that case we will return -1. So in this way we can solve this, and our space complexity will be order of 1. So do we have a better approach? Yes, we have. What could be the other better approach? We can sort this array. So what will happen if we sort this array? So when we sort this array, so for example this one, if we sort this array, right? So it would become 2, 3, 3, then 4, 4, 4, 4, right? And then we can count continuously how many times it has been repeated. So it is one time only. So the count is 1 of maximum element. When we go over here, then we go to the next element, the count has become 2. When we go to the next element, the count is the element is different, so the maximum count is 2 right now for 3. And when we go to 4, so the count is 1, then 2, then 3, then 4, then the array ends. So the maximum count is 4 and the element is 4. Again we see the same second part of the logic, it is lesser than it is not greater than n by 2, so we will be returning minus 1. So in this way, while sorting we can by sorting we can solve this problem. So with sorting we know the time complexity of sorting is n log n. The merge sort or the quick sort, the average time complexity and the worst time complexity is n log n, and the space complexity would be order of 1 only. We are not using any extra space. What could be the other approach? We can store the frequencies. We have already solved many problems on hashing. So we can have a hash map or hash or set, and we can store the frequencies. So for example, this one 3. So 3 has come, 3 is not in the map. We store the 3 in the map and increase its count by 1, and again 3 comes, it is there in the map, we will increase the count by 2. 4 is not there, 4 will store in the map, increase the count, and that way we can find at the end that the count whose count is maximum. We can just traverse through the map and we will see that the count of 4 is maximum, and when we see if the count is greater than n by 2, yes it is greater than n by 2, then we will return it 4. Here it won't be greater than, we will return again minus 1. So with hashing we can solve this, and for this the time complexity would be order of n. We have reduced it to from n log n to order of n, but the space complexity will also be at the worst, every case of actually. Not the worst case, it would be order of n. The number of unique elements in the map, right? And including the count also. So yeah. So the space complexity for hashing will also be order of n. So in 3 ways we have solved it, but we have not got any approach where the time complexity is order of n and also the space complexity is order of 1. Do we have any such approach? That would be the optimized approach. Yes, we have an algorithm by which we can solve this in order of n time complexity as well as order of 1 space, and that algorithm is Moore's voting algorithm. So let's discuss how can we solve it. Like what is the intuition of this? We don't need to. We are not going to take any extra space. We can't use sorting. We can't use hashing. But we need to find the majority element. What observation or what do you think can we use to solve this? So I think like in the elections also we have voting, right? Whoever if for without any coalition government, if you want to win, then you have to get the greater than the half of the votes, right? So that's why its name probably is voting algorithm, and I think Moore would have designed it. So its name is Moore's voting algorithm. So voting, right? So at every one thing you can see in this example, the values are same, just that the number of elements are 8 here and there is one more 4, right? And for that 4, the count of 4 has become more than n by 2, and we have a answer. We have a majority element in this example, but we don't have when we have removed this 4. So at every point, if we add again, then the value of the majority element can change. So we can think that at every point, like if we have we might have a different answer over here, right? Suppose here 3, 3, 4. What would be the majority element if these 3 elements are there? 3 would be the majority element. But if we include 3, 3, 4, 2, so there will be no majority element, because 4 by 2 is 2 and 3 has come twice. So we don't have it. So at every point, whatever is the element, its count has to be greater than n by 2. if it is not greater than n by 2, then at that point of time it is not a majority element. Can we use this observation to solve this problem? Yes, we can. How? So let me write the code and then explain. So it would be easier, right? Or I can explain it here also. Okay, let me explain it and then I'll write and then I'll explain again. So suppose I traverse the array and I see 3 has come once. Okay. So if this is just the answer, so our majority element is 3. I store the count as 1. I go to the next element. Now 3 has come twice. Here also the majority element is 3 and the count of 3 is 2. Now I have got another element 4. Okay. Here also the majority element is 3 only. And the count is also 2. Count is 2. But the thing is, here the element has come different. And here one element has increased, which is not 3. So if I go over here again and if it is not 3, then at that point of time 3 won't be our majority element. So suppose at this point of time, whenever we get an element here, 3 was the majority element. When the next element is not a majority element, then can we reduce it? Reduce the count of 3 by 1. So that next element again if we get, which is not 3, which is not the majority element at that point of time, the count of that element should be reduced. Assume 3 is the majority element. Okay. So at every point, we need to ensure that the count of 3 is becoming, the count is actually the number of times it is greater than n by 2. Okay, we need to ensure that way, because one element, if we assume, let us be sure that there is a majority element. Okay, we know in the answer there is a majority element. So at every point of time, when we get an answer, if we have a count of it and if it doesn't come again, then the chance of him becoming a majority element is decreasing. So that count is decreasing, so we will reduce that count. Okay, so when I will code it, it will become more clear. So let's go through the solution. So 3 has come once, 3 has come twice, 3 has not come here, the majority element has not come. So I will reduce the count of 3. So the count of 3 will become 2 minus 1, 1. Again, I don't get the majority element, 3. I'll always check if the majority element has come or not. So again, we will decrease the count. So the count of the majority element will become 1 minus 1, 0. That's why here till here there is no majority element. Okay, we'll have every point we will have the answer. If we have count more greater than 0, we have a majority element. Okay. Now here the count is 0 and we get a 4 over here. So whenever the count is 0, and when we get any element, at that point of time that element is the majority element. Till here, when the count was 0, we don't have a majority element. Let's forget this. Because 2 elements have come that are not 3. So the chance of 3 is gone. 3 is not going to be majority element till here. So now we get another element and we don't have any majority element till here. So that element becomes the majority element. This is our algorithm, Moore's voting algorithm. So here the count becomes 1. Okay, and the majority element is 4. Here we come, again the majority element is same. So count becomes 2, majority element is 4. Again we don't get a majority element this time, 2. So the count will reduce. The count will become 1, majority element will still be 4. Since the count is not 0, we are not going to change. Again we get a 4. So the count becomes 2, majority element is 4. Again we get a 4. Count becomes 3, majority element is 4. So the count is 3. From the average n by 2, 3 more counts are there. As we consider this is not there, so we have when the traversing is finished, and what is the majority element that we have got? 4, right? So after that, what we will do? we will check how many times 4 has come. Till here we know that the 4 has come thrice, but 4 might have come more than 3, right? So here actually, yeah, okay, because we are reducing also, right? So we will check whether there is a majority element or not. Whatever majority element candidate we have got for, is it actually coming more than n by 2 times or not? Because we are reducing the count also, right? When we don't get 4. So we will traverse this and we will check again. So again we will traverse. So order of n plus order of n, that is actually order of n only time complexity. So we see that the 4 has come 5 times and it is greater than n by 2. So whatever the answer we have got as a majority element, that is actually a majority element. Let me code this and let me dry run this. Then I think you have understood the intuition, right? Because every point of time we need to have a majority element. So the count would be always greater than the 0, right? If we don't get the majority element, that point of time, that means its count is decreasing, right? So at every point we are checking our majority element. After the end of the array, whatever majority element we get, we will see whether that element is a majority element or not. Otherwise, there can't be a case where we traverse, we don't get a majority element with this algorithm. We get a different majority element at that algorithm. For example, here the count is 3. I give 5, 4, 6. The count will 5, 7, 6. The count will become 0 because 4 is not coming twice. And again I will give 100. And the count becomes 1 and the element is 100. But element 100 has come only once over this traversal. There is no, so it cannot be, there won't be any case that some other element would be the majority element and 100 won't be the majority element. That is for sure. But there is no way that any other element would be the majority element, because that has not come more than n by 2 times. If it would have come more than n by 2 times, then its count would obviously be more than 0, right? That is the point that algorithm checks. And then we go again and we see whether that element has come more than n by 2 times or not. Okay, so let me code it. So we have int count equal to 0, and we have a element, say we store -1 if there is no anything we can store, or we don't need to store also. Could be a int mean value also, right? Yeah, anything because -1 could be present in there. So we will traverse this 0 to -1, and if count is equal to 0, then what we will do, element would be our AI, and we will increase the count also, count plus plus. Okay, else if AI equal to element, then what will happen, we will increase the count plus plus, right? Else if it is not going to be there, then we will decrease the count, right? And this is there, and whatever element's value is there, we will traverse the array again for I equal to 0 to n minus 1. Okay, and if AI equal to element, that means, and we will increase, so count we will make it again as 0, because we want to get the latest actual count, and we will do a count plus plus whenever this is there. And now if count is greater than n by 2, then we will return the element. else we will return -1. So let me try run this code for say this example. Okay, so we start this. Okay, 3 is equal to, the count is 0 in the beginning, so our element majority element becomes 3. Okay, and count becomes 1, right? C is equal to 1, M equal to 3. Now again we have got 3, it would come over here, yeah, so count would become 2, count becomes 2, our majority element is 3 only. Now again, now we see that count is not 0 when it came over here, count is not 0, and the 4 is not equal to 3, so this also won't come, so it would go over here. So what is going to happen over here? Count would be decreased. So count becomes 1, majority element is still 3, right? And now again we get 2. So 2 is not equal to, count is not 0, and count is not equal, 2 is not equal to 3, and so again our count would decrease. So count becomes 0, our majority element is 3 till here, right? And then what is the next element? 4. But the count is 0. So what will happen? 4 will become our majority element and count will increase. So count will increase 1 and majority element will become 4. Here again 4 comes, so count is not 0 now, count is 1. AI is equal to 4 is equal to 4, so count will increase. Count becomes 2, majority element is 4. Right? Again now 2 comes, 2 is not equal, count is not 0, 2 is not equal to 4, so count would be decreased. So count becomes 1. Majority element is 4 again. Right? And again 4 comes, so count becomes 2 and majority element is 4. This condition would satisfy, right? So what is the majority element that we have got? 4, right? But is it has it come more than n by 2 times? So we make the count as 0. We have got our majority element and we count how many times that majority element has come. Okay, so when we will traverse this again, so we'll have our count as 1, 2, 3, 4. So count's value is 4. And then we check whether this count is greater than n by 2 or not. So what is the value of n? 8. 8 by 2 is 4. Is 4 greater than 4? No, 4 is equal to 4. That means this condition won't be satisfied and this should be satisfied and -1 would be returned. So with this Moore's voting algorithm, we can find the majority elements in order of n time complexity, and the space complexity is also order of 1. I hope the intuition is also clear, the coding, the code part is also clear, the logic is clear. The link to the question has been given in the description. Please try it yourself and then come to the code walkthrough section.
Here is the code walkthrough section of the 17th question, majority element. So we have implemented this Moore's voting algorithm. This has to be solved in order of n time and order of 1 space. So I've already explained the solution. So we have just implemented it. We have the candidate over here. We get the element, and then we check whether this element's count is greater than the count of n by 2 or not. So if it is, then we return the element, otherwise we return as -1, which is told to be returned if we don't have a majority element. So let me run it. It has passed the test case, so let's submit this. So it has worked fine. So let me know in the comment section how was the explanation, and see you all soon in the next video. Thank you. Jai Jinendra.